All right, let's talk about divergence of a, tests for convergence of a series. There are many tests we can use to decide whether a series converges or diverges. In this section, we will discuss the divergence test, the integral test, and the D'Alembert's ratio test. Theorem: if the sum, if a series, this essentially is just saying that if a series converges, the lim as n approaches infinity of the sequence of the nth term is 0. Are you listening? This says if a series converges, then the limit to infinity of the nth term of the sequence is 0. Essentially, that's what it is saying. Note, the converse is not true. If the lim as n approaches infinity of the nth term of the series or the sequence is 0, does not necessarily converges. The series does not necessarily converges. So if it is converges, the lim as n approaches infinity is equal to 0. But if the lim to infinity, the converse is not necessarily what? True. That's what they're saying. The integral test, essentially the integral test says, suppose that f of x is a positive decreasing function. So that is the condition for this to work. F of x must be a positive decreasing function for values of x greater than or equal to k. And f of n is equal to un, which is the general term of this what? Sequence. Or the general term of the what? Series. Now, if the integral from k to infinity of f of x is convergent, the series is also what? Convergent. But if the integral from k to f of x is divergent, then the series is also divergent. Note that this test does not give the value the series converges to. If it converges, it simply tells us whether the series converges or diverges. All right, so next we can have a look at example 23. All right, so example 23 says we're to show that this series diverges. First of all, I observe that un, so un, which is 1 over n, is a positive decreasing function. So f of un, circle, or f of n is equal to 1 over n. Now, if the integral from 1 to infinity of f of x dx, if this diverges, the series also what? Diverges. So this is actually equal to the integral from 1 to infinity of 1 over x dx. And if we integrate 1 over x, we're going to get what? ln x. And this is from 1 to infinity. So this is ln infinity minus ln 1. So what's the log to the base e of infinity? Log to the base e of infinity. So what must I raise x to e? So it must be infinity. This is infinity. Now log to the base e of 1 is 0. So it's equal to what? Infinity. Sorry, this is equal to infinity. If it's equal to infinity, it means that the function what? From 1 to what? In the integral of the function from 1 to infinity diverges. Therefore, the series also what? Diverges. So we probably need to make a statement that since the limit from 1 to infinity of f of x dx diverges, the series from 1 to infinity of 1 over n also diverges. All right.